The volcanic soil of Peleliu Island turned to black mud under the tropical downpour as Corporal Jimmy Nakamura crouched beside his M4 Sherman tank on the morning of November 3, 1944. His hands, blackened with grease and carbon scoring, gripped a cutting torch he had no authorization to use on government property. The tank's right track lay in sections around him, 3 tons of manganese steel that had carried his crew through 2 months of island combat and was now supposed to carry them through one more night. 200 yards down the coral ridge, Marine intelligence estimated 300 Japanese soldiers were massing for what would likely be the final Banzai charge against the American perimeter. Nakamura had 4 Sherman tanks, 16 crew members, and one idea that violated every page of the technical manual, currently serving as a makeshift seat cushion in his driver's compartment. The official Army Ordnance specification for Sherman track maintenance was explicit. Damaged track blocks must be replaced with factory components using prescribed pin and connector assemblies. Field modifications are prohibited due to structural integrity requirements and liability concerns. Nakamura had read those specifications exactly once, during his abbreviated training at Fort Knox in April 1944. He'd watched demonstration mechanics explain why the T-48 rubber block track required precision-manufactured components that couldn't be replicated in field conditions. The engineering seemed sound. Each track block was designed to specific tolerances, heat-treated to precise hardness levels, and assembled with connector pins rated for 50,000 pounds of shear stress. But Nakamura had grown up in Sacramento's Japantown before the war, where his father ran a small welding and fabrication shop that took on repair work other shops wouldn't touch. By age 13, Nakamura was calculating heat penetration for dissimilar metal joins, learning through trial and error how steel behaved under thermal stress in ways that contradicted his high school shop teacher's textbook assumptions. He'd carried that knowledge into the army, where it had already earned him 2 written reprimands for unauthorized equipment modifications, once for reshaping his tank's tow shackles to prevent them from catching on jungle vegetation, once for modifying the turret storage racks to carry additional ammunition in violation of the weight distribution specifications. And now he was contemplating his biggest violation yet. The track section lying at his feet wasn't just damaged, it was destroyed. A Japanese 47mm anti-tank gun had punched through 3 consecutive track blocks during that afternoon's firefight, shearing the connector pins and warping the guide horns beyond any hope of standard repair. Ordnance protocol said, "Radio for replacement track sections and wait for supply convoy." But the nearest supply depot was 18 miles north at the beachhead. The road was contested after dark, and the Japanese attack would come sometime between midnight and dawn, according to every pattern they'd established over the previous 60 days. If Nakamura followed procedure, his tank would still be sitting here immobile when 300 enemy soldiers came screaming out of the darkness. If he violated procedure and his repair failed under combat stress, his tank would throw its track at the worst possible moment, likely killing his crew when they became a stationary target. The math was brutal either way. Nakamura pulled a worn notebook from his tool bag, the same notebook where he'd been documenting track wear patterns and failure modes since landing on Peleliu in September. The pages contained observations that would have interested the engineers at Chrysler's tank arsenal if those engineers had ever asked tankers what actually broke in combat versus what the test range predicted. Standard T-48 track blocks failed most commonly not from enemy fire, but from the connector pins, working loose after repeated impact stress on coral terrain. The pins were designed with an interference fit that required hydraulic presses to install, making field replacement theoretically impossible. Except Nakamura had been replacing them for 6 weeks, using a technique that involved controlled heating of the bushing, rapid cooling of the pin, and a 20-pound sledgehammer applied with precision that came from years of watching his father join railroad rail sections. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But tonight's problem went beyond pin replacement. The track blocks themselves were compromised, the rubber pads torn away, the steel bodies deformed. Ordnance manual said those blocks were unrepairable. Nakamura's notebook said otherwise. He'd been studying how the Japanese repaired their Type 97 Chiha tank tracks, salvaged from destroyed vehicles, and examined during rare moments when the front line stabilized enough for such investigations. The Japanese didn't have supply chains bringing factory-fresh components to the front. They had welders joining cracked track plates back together with whatever steel they could scavenge. The welds were crude, the repairs ugly, but Nakamura had noticed something the ordnance engineers apparently hadn't. Those crude repairs often outlasted the original track blocks because the welded sections were actually stronger than the pins holding undamaged blocks together. James Hiroshi Nakamura had been asking, why not, since childhood, a trait that served him poorly in institutions that valued because the manual says so as sufficient explanation. Born in 1,922 inches, Sacramento, California, Nakamura grew up watching his father's fabrication business adapt to survive the Depression's relentless economic pressure. The elder Nakamura took on repair jobs that other shops refused, not because they were particularly profitable, but because turning away work meant going hungry. When the Southern Pacific Railroad needed an emergency track switch repair in 1935, every established contractor bid using standard replacement components that would take 6 weeks to deliver. Nakamura's father examined the fractured rail for 2 hours, then welded a splice joint using salvaged steel and a technique he'd learned in Japan before immigrating. The railroad inspectors tested it, approved it, and gave him 3 more repair contracts. That problem-solving approach became young James's default framework for viewing the world. At Sacramento High School, his shop instructor wrote on one report card, "James shows exceptional mechanical aptitude, but lacks respect for established procedures and specifications." When Nakamura tried to enlist in the Army in January 1942, 1 month after Pearl Harbor, that assessment followed him into a military that didn't quite know what to do with Japanese-American citizens who wanted to fight for their country. He spent 6 months in bureaucratic limbo while the War Department decided whether Nisei soldiers were security risks or assets. By July 1942, policy had shifted enough that Nakamura received orders to report to Fort Knox for tank training, though he spent the first week being interviewed by intelligence officers who seemed more interested in his family's pre-war activities than his welding skills. The M4 Sherman captured Nakamura's attention immediately when he first climbed into one during training in August 1942. The tank was revolutionary in American terms, the first medium tank that combined adequate armor, reliable mobility, and a 75mm main gun capable of defeating most Axis armor. At 30 tons, combat-loaded and powered by a 400-horsepower radial engine, the Sherman could sustain 25 miles per hour across rough terrain. But the tank's tracks fascinated Nakamura more than its weapons. The T-48 rubber block track was an engineering compromise between durability and weight. Each block combined a steel shoe with a molded rubber pad that provided traction while reducing ground pressure. The rubber cushioned road shock and reduced track noise, advantages that looked good in test reports but created vulnerabilities that became apparent only in combat. The rubber degraded rapidly in tropical conditions. The steel shoes cracked under repeated impacts against coral and volcanic rock, and the entire assembly relied on connector pins that were precision manufactured to tolerances that couldn't be replicated in field workshops. Nakamura started documenting track failures during training exercises, carefully noting how blocks behaved under different stress conditions. He discovered that the rubber pads, while providing excellent traction on soft ground, actually reduced track life by preventing the steel shoes from seating properly against the drive sprocket teeth. On hard surfaces like coral or volcanic rock, the rubber absorbed so much impact energy that the steel bodies fatigued faster than equivalent all-steel tracks. He wrote up his observations and submitted them through his training company commander. The report came back with a single sentence. Corporal Nakamura is reminded that tank component design is established by Ordnance Department testing using comprehensive evaluation criteria beyond the scope of field observation. The first official reprimand came at Camp Pendleton in March 1944. Nakamura's tank company was conducting amphibious landing exercises when his Sherman threw a track climbing out of the surf. Standard procedure called for recovery vehicle assistance and replacement track sections from the beach supply dump. Nakamura examined the failure and realized the connector pins had corroded from saltwater exposure, something the training manual mentioned as a concern but provided no field solution for. He heated the corroded pins with a cutting torch until they expanded enough to drive out, then fabricated replacement pins from salvaged tow cable, creating an interference fit that actually exceeded the original pin specifications. His platoon commander put him in for a commendation for initiative. His battalion maintenance officer gave him a written reprimand for unauthorized modification of primary combat equipment. Both actions appeared in his service record. The second reprimand arrived in July 1944 during the Marshall Islands campaign. Nakamura had modified his tank's track tension adjustment procedure, adding a witness mark system that let the driver verify proper tension by visual inspection instead of requiring the assistant driver to measure slack with a ruler, as the manual specified. The modification saved approximately 4 minutes during pre-combat checks and reduced the likelihood of throwing a track due to improper tension. When an inspection officer discovered the unauthorized marks painted on the suspension arms, Nakamura was restricted to base for 1 week and required to remove the modifications. His company commander privately told him the system was brilliant, but that brilliant didn't matter if it appeared in no technical manual. The third reprimand came just 3 weeks before Peleliu, during operations on Guam in September 1944. Nakamura had developed a field repair technique for cracked volute spring assemblies, the suspension units that absorbed road shock between the tracks and hull. The standard procedure required replacement of the entire spring assembly, a job that took 6 hours and required a crane. Nakamura's method involved welding reinforcement plates to the cracked housing, a repair that took 40 minutes and could be performed with tools carried on the tank. He taught the technique to every crew in his company. They became the only tank unit in the division that hadn't lost operational vehicles due to suspension failures. Then a maintenance. Inspection officer observed the welded repairs during a rear area inspection and wrote Nakamura up for introducing unauthorized structural modifications that could compromise crew safety if the repairs failed under combat load. Each reprimand came with the same warning: one more violation and Nakamura would face court-martial proceedings. His service record became a contradiction, filled with combat efficiency, reports praising his technical skill alongside disciplinary actions for procedural violations. Captain Thomas Chen, Nakamura's company commander on Peleliu, had pulled him aside in October and been direct. "Corporal, you're the best tank mechanic I've got, and the worst garrison soldier I've ever seen. The army doesn't know what to do with people like you, and honestly, neither do I. Just try to keep your head down until we finish this island." But keeping his head down was precisely what Nakamura couldn't do on November 3rd, looking at 300 enemy soldiers massing for an attack and one immobile Sherman tank that represented the difference between holding the perimeter and being overrun. The physics that Nakamura had worked out in his notebook represented a direct challenge to the Army's fundamental assumptions about the Sherman's track system and what constituted acceptable field repair. The Ordnance Department had established doctrine based on testing at Aberdeen Proving Ground, in Maryland, throughout 1942 and 1943, determining that T-48 track components must maintain specific tolerances to prevent accelerated wear and catastrophic failure. The reasoning seemed sound on paper. The track blocks had to maintain precise dimensional relationships with the drive sprocket, return rollers, and road wheels. Any deviation would create uneven load distribution, leading to rapid wear or sudden failure during high-stress maneuvers. But Nakamura's fundamental disagreement wasn't with the engineering principles. It was with the assumption that precision manufacturing was the only path to durability. The Japanese tanks he'd examined used cruder components that violated every tolerance specification the Americans considered essential, yet those tracks often lasted longer in combat conditions because they were designed to be repairable rather than replaceable. The welding technique Nakamura was contemplating would create track blocks that looked nothing like factory specifications. Instead of replacing the 3 destroyed blocks with identical components that didn't exist on Peleliu, he would salvage steel from the damaged blocks, weld them into composite sections that were probably 15% heavier and definitely 0% compliant with technical orders, and hope they held together long enough to get through one night of combat. The alternative was following procedure and watching his tank sit useless while 300 Japanese soldiers attacked a perimeter that was already undermanned and overextended. Nakamura made his decision at 1,647 hours on November 3rd, pulling his cutting torch from the tool rack and ignoring the voice in his head that sounded disturbingly like the maintenance officer who'd written his last reprimand. The first step was salvaging usable steel from the destroyed track blocks. Nakamura used the cutting torch to remove the damaged connector bosses and guide horns, setting aside the pieces that were still structurally sound. The center sections of all 3 blocks were cracked but not shattered, meaning the steel itself wasn't compromised, just deformed beyond the point where it would seat properly against the sprocket teeth. He fired up his portable welding generator, a gasoline-powered unit that was technically assigned to the maintenance platoon, but had somehow ended up permanently borrowed by Nakamura's crew. His driver, Private Eddie Morrison, positioned the damaged track blocks on a makeshift welding table fabricated from ammunition crates and helped Nakamura clamp them into alignment. The repair technique Nakamura employed would have given any ordnance inspector a heart attack. He was essentially creating 3 custom track blocks by welding together sections of destroyed blocks, building up damaged areas with weld metal until the assembled pieces matched the approximate dimensions of factory components. The guide horns that located the block against the drive sprocket welded on from salvaged sections. The connector bosses that held the pins joining blocks together built up with multiple weld passes until they achieved sufficient thickness. Private Morrison watched the process with growing concern, finally asking the question both of them were thinking. "Corporal, if those welds crack under load, we're going to throw track in the middle of whatever happens tonight." Nakamura paused his welding, flipped up his hood, and looked at Morrison directly. "If we don't do this, we're not going into whatever happens tonight. We'll be sitting here watching while the rest of the company fights without us." The welding took 4 hours, working with constant interruptions to let the steel cool enough to prevent thermal warping. Nakamura used a technique his father had taught him for joining dissimilar thickness materials, building up the weld in multiple thin passes rather than trying to fill the joint in a single heavy bead. Each pass had to cool to black heat before adding the next layer, preventing the kind of thermal stress that would crack the weld later under combat loads. By 2100 hours, Nakamura had 3 completed track blocks that looked like they'd been salvaged from a scrapyard and welded by someone who'd learned the trade from a badly translated manual. The welds were ugly, the dimensions were approximate, and the weight was probably 20% higher than factory specifications. But the steel was sound. The structural integrity was actually superior to the original blocks because the welded sections eliminated the stress, concentrations created by connector pins, and it was time to find out if theory matched reality. Installing the repaired track sections required help from the entire crew. The blocks had to be positioned in the gap where the damaged sections had been removed, aligned so the guide horns engaged the drive sprocket teeth, and connected to the existing track sections with pins that Nakamura had fabricated from salvaged driveshaft material. The pins were oversized by approximately 0.0 to 1 inches, requiring Nakamura to heat the connector bosses with his torch before driving the pins home with a sledgehammer. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The final pin went in at 22:47 hours. Nakamura signaled Morrison to start the engine and slowly tension the track. The Continental R975 radial engine coughed to life, the transmission engaged, and the drive sprocket began rotating, forward. The welded track sections engaged the sprocket teeth, flexed over the road wheels, and wrapped around the return path exactly as they were supposed to. Nakamura watched for any sign of the welds cracking, any indication that his repair was about to fail catastrophically. The track completed 3 full rotations without incident. Morrison shut down the engine, and both men sat in silence for a moment, processing what had just happened. It shouldn't have worked according to every technical manual and every engineering specification, but the welded track blocks were functioning exactly like factory components. Better than factory components, actually, because the welded construction eliminated the connector pins that typically failed first under impact loads. Captain Chen arrived at 2,315 hours, making his pre-battle inspection of the tank positions. He saw Nakamura's Sherman with its engine running and tracks tensioned, exactly where it was supposed to be in, the defensive line. Then he noticed the welding equipment and the pile of cut steel that had been sitting there 4 hours earlier. "Corporal Nakamura, please tell me you didn't do what I think you did." Nakamura met his eyes but said nothing. Chen walked around the tank slowly, examining the right track in the glow of his flashlight. The welded sections were obvious even in darkness, the fresh weld metal still showing slight discoloration from the heat. Chen squatted down and tapped one of the welded blocks with his knuckles, a gesture that seemed to help him think through what he was about to say next. "You understand that field welding structural track components violates about 12 different technical orders. You understand that if that track fails and your tank is disabled, I'm going to have to explain to battalion why my tank was combat ineffective due to unauthorized repairs." Nakamura nodded slowly. Everything Chen said was factually correct. Chen stood up, brushed volcanic dust from his uniform. "You also understand that we're about 6 hours from the biggest fight this company has seen, and I need every tank I've got on the line. So here's what's going to happen. You're going to button up that tank, you're going to take your assigned position, and you're going to not mention this repair to anyone unless that track actually fails. If it holds, we'll call it field expedient maintenance and deal with the paperwork later." The Japanese attack came at 0342 hours on November 4th, 1944, announced by a cascade of mortar rounds that walked across the American perimeter with practiced precision. Nakamura was in the driver's position when the first explosions hit, his hands already on the controls, engine idling at low RPM to keep the tank responsive. Through his vision port, he could see muzzle flashes erupting from the coral ridge 200 yards distant, more flashes than he'd seen in any previous engagement on Peleliu. The tactics were standard for Japanese forces in the final months of 1944. Artillery and mortar preparation to suppress defensive positions followed immediately by a massed infantry assault designed to overwhelm defenders through sheer numbers before American artillery could respond. The approach had worked at Tarawa, worked at Saipan, and came terrifyingly close to working at Guam. Whether it worked tonight depended largely on whether 4 Sherman tanks could do the work of an entire infantry company. Captain Chen's voice crackled over the radio net. "All Cobra elements, prepare for contact. Infantry assault estimated 300 plus, approaching from Northwest Ridge. Engage at maximum effective range, conserve ammunition, do not advance beyond assigned positions." The last instruction was critical. Tank crews had a natural tendency to push forward during combat, seeking better firing positions or attempting to overrun enemy positions. But Peleliu's terrain punished that aggression. The coral ridges created natural, anti-tank obstacles. The volcanic soil turned to impassable mud during rain, and the Japanese had seeded every approach with magnetic anti-tank mines that could disable a Sherman with a single well-placed charge. The defensive plan was simple. Stay in prepared positions, use the tanks as mobile pillboxes, and let the infantry come to them. Nakamura's gunner, Corporal Michael Santos, had the 75mm main gun loaded with high-explosive rounds specifically designed for anti-personnel work. The coaxial 30-caliber machine gun was loaded and ready, 3,000 rounds of linked ammunition feeding from racks that Nakamura had modified during that previous unauthorized equipment alteration. The tank's role tonight wasn't armor engagement. It was infantry suppression at ranges where individual rifle fire would be ineffective. The first wave of Japanese soldiers appeared at 0347 hours, emerging from the coral ridge in a loose skirmish line that quickly condensed into the characteristic Banzai formation. The tactic looked suicidal from an American perspective, hundreds of soldiers charging directly into prepared defensive fire with bayonets fixed and minimal covering fire. But the Japanese had calculated the mathematics differently. If they could close the distance before the defenders could inflict sufficient casualties, they could break through the perimeter through sheer momentum. The equation required accepting horrific losses in exchange for tactical success, a trade-off that American commanders found incomprehensible but Japanese doctrine considered acceptable. Santos opened fire with the main gun at 175 yards, aiming for the center of the assault formation. The 75mm high-explosive round detonated at waist height, the fragmentation pattern designed to maximize casualties against personnel in the open. Nakamura couldn't see the impact from his driver's position, but he heard Santos report. Target, multiple casualties, reloading. The loader, Private James Lee, had the next round chambered in less than 5 seconds. Santos fired again, adjusted aim slightly left, fired a third time. The tank rocked with each shot, the recoil absorbed by the suspension but still transmitted through the hull as a sharp percussion that Nakamura felt through his seat. Between main gun rounds, the coaxial machine gun maintained steady fire, Santos walking the tracers across the assault formation like a fire hose spraying water. The first test of Nakamura's welded track repair came at 0351 hours, when he needed to pivot the tank 19 degrees right to give Santos a better firing angle at a group of Japanese soldiers attempting to flank the position. The turn required the right track to carry additional load, while the left track provided steering, exactly the kind of asymmetric stress that the Ordnance Department warned could cause field-repaired components to fail. Nakamura applied power to the steering levers, feeling the tank rotate smoothly. The welded track sections handled the turning load without any of the binding or juddering that would indicate structural failure. 4 months of watching Sherman tanks maneuver in combat had taught Nakamura exactly what track failure felt like. The characteristic shudder as cracked blocks came apart, the sudden loss of tension as pins sheared, the catastrophic lurch when an entire section let go at speed. His repaired track showed none of those symptoms. The second wave came at 0403 hours, larger than the first. Perhaps 150 soldiers in a concentrated mass aimed directly at the gap between Nakamura's tank and the next Sherman in line. The Japanese had identified the weakest point in the American perimeter and were committing everything to exploiting it. Santos shifted fire to the new threat, but the main gun could only engage one target at a time. Between shots, dozens of enemy soldiers were crossing ground unchecked. Nakamura made a decision that contradicted Chen's explicit orders about remaining in assigned positions. He advanced the tank 40 feet forward, closing the gap in the defensive line and positioning the Sherman where its machine guns could provide interlocking fire with the adjacent tank. The maneuver required crossing a drainage ditch that ran perpendicular to the American positions, a natural obstacle that would test the repaired track under the worst possible conditions. The Sherman nosed down into the ditch at a 17-degree angle, the front glacis plate nearly vertical as the tank descended. The suspension compressed fully, transferring maximum load to the tracks. Nakamura felt the right track take the strain, felt the welded sections flex as they wrapped around the drive sprocket teeth and road wheel rims under combat load. For 3 seconds that felt considerably longer, he waited for the catastrophic failure that would leave his tank stuck in a drainage ditch during a frontal assault. The tank climbed out of the gnome, ditch without incident. The welded track sections held. Nakamura positioned the Sherman in its new location, and Santos resumed firing, now able to engage targets that had been in dead space before the maneuver. The third wave hit at 0418 hours, and this time, the Japanese modified their tactics based on what they'd learned from the previous assaults. Instead of massing in a single formation, they attacked in multiple smaller groups spread across a wider front, making it impossible for the Sherman tanks to concentrate fire effectively. Some groups carried magnetic anti-tank mines, clearly intending to close with the American armor and disable it through direct attack. Others advanced with Bangalore torpedoes, designed to breach the wire obstacles protecting the perimeter. The assault was coordinated, professional, and represented everything the Japanese could throw at this section of the American line. Nakamura's tank was no longer firing selective targets. Santos was engaging anything that moved within 300 yards, the main gun firing every 8 to 10 seconds as fast as Lee could reload. The barrel was overheating, the recoil mechanism was taking stress beyond its design specifications, and somewhere in the turret mechanisms, components were wearing at accelerated rates that would require depot-level maintenance if they survived the night. At 0433 hours, disaster nearly struck from an unexpected direction. A Japanese soldier emerged from a shell crater 15 yards from Nakamura's tank, carrying a magnetic anti-tank mine that he was attempting to place against the hull armor. The tank's bow machine gunner, Private Chen Rodriguez, saw the threat and opened fire with the .30 caliber ball mount, but the gunner's angle was wrong. The Japanese soldier made it to the tank's right side, directly over the welded track section that Nakamura had repaired 6 hours earlier. Rodriguez couldn't depress his machine gun enough to engage. Santos couldn't traverse the turret fast enough to bring weapons to bear. For approximately 4 seconds, the Japanese soldier was in a perfect dead zone, where no American weapon could touch him. Then Morrison, who'd been observing through the driver's vision port, did something that violated every page of the tank crew manual. He released the brake, applied full power to the right steering lever, and spun the tank in a violent pivot turn that caught the Japanese soldier between the moving track and the ground. The crushing force was instantaneous and lethal. The tank completed its rotation, Morrison reset to neutral, and combat resumed as if nothing had happened. Except, something had happened that went beyond saving the tank from a magnetic mine. Morrison's emergency maneuver had subjected the repaired track to approximately 3 times its normal operating stress. The welded sections had absorbed rotational torque, ground pressure, and impact loading simultaneously, the exact combination of stresses that the Ordnance Department insisted would cause field repairs to fail catastrophically. Nakamura's repair held without even a suggestion of structural distress. The fourth wave came at 0447 hours, smaller than the previous assaults but more desperate. These were the final reserves the Japanese commander had available, perhaps 70 soldiers making one last attempt to break through before American artillery could saturate the area. They advanced through their own casualties, using the bodies as cover, firing as they moved in a technique that suggested these were experienced infantry, rather than the hastily trained replacements that had made up earlier waves. Santos shifted to high-explosive rounds with delay fuses, aiming for impacts that would detonate after penetrating the ground and throwing coral fragments in addition to shell fragments. The effect was devastating against infantry in the open. The Japanese assault stalled at 100 yards, broke apart at 80 yards, and collapsed entirely at 60 yards, when the survivors realized they'd lost too many men to achieve breakthrough, even if they reached the American positions. By 0512 hours, the attack was over. The coral ridge that had been packed with assault troops 40 minutes earlier was now empty except for casualties. Marine infantry began advancing from their own positions, carefully clearing the impact area and ensuring no Japanese soldiers were feigning death to attack later. Nakamura shut down his tank's engine at 0524 hours, the sudden silence after 90 minutes of continuous combat feeling somehow louder than the gunfire had been. His crew emerged from the tank slowly, their movements mechanical from exhaustion and the after-effects of sustained combat stress. Santos had fired 63 main gun rounds, more than any previous engagement of the campaign. The machine guns had expended approximately 2,000 rounds of .30 caliber ammunition. The tank's engine had run at combat power levels for 90 straight minutes, stressing the transmission and final drives beyond normal operational limits. And the welded track repair that Nakamura had fabricated from damaged components and unauthorized welding techniques had performed flawlessly through maneuvers that would have tested factory-fresh track sections. Captain Chen arrived at 0607 hours, accompanied by the battalion maintenance officer, Lieutenant Richard Park. Park was a West Point graduate who'd come up through the formal military engineering education system. He believed in specifications, in testing protocols, in the systematic approach that the Ordnance Department used to qualify every component before authorizing field use. He'd written 2 of Nakamura's previous reprimands and made no secret of his opinion that field modifications were violations waiting to cause casualties. Park walked directly to Nakamura's tank and examined the right track without greeting anyone. He spent 5 minutes inspecting the welded sections, measuring with calipers, checking for cracks with a magnifying glass. Finally, he stood up and addressed Nakamura directly. "Corporal, these track blocks are not manufactured to specification." Nakamura nodded. There was no point denying what was obvious. These track blocks were fabricated using unauthorized welding procedures. Park continued. These track blocks should have failed catastrophically under combat loading, according to every engineering analysis the Ordnance Department has conducted. Another nod. Chen intervened before Park could continue. "Lieutenant, those track blocks kept this tank operational during an assault that could have overrun our position if we'd been short even one vehicle." Park turned to face Chen, his expression suggesting he didn't appreciate company commanders interfering with maintenance procedures. "Captain, that tank was operational despite unauthorized repairs, not because of them. Corporal Nakamura got lucky that his welds held. Next time, they might fail and get his crew killed. We have specifications for a reason." Chen's response was carefully measured. "Lieutenant, we have a tank that was supposed to be deadlined waiting for replacement components. Instead, it was combat effective and contributed to defeating a 300-man assault. I'm going to write that up in my after-action report. You can write whatever you want in yours." The tension between field expedience and institutional procedure crystallized in that moment on the volcanic soil of Peleliu. Park represented the engineering orthodoxy that insisted proper procedures prevented catastrophic failures. Chen represented the combat reality that sometimes proper procedures guaranteed failure by leaving units combat ineffective. Nakamura represented the uncomfortable middle ground where violations worked better than compliance. Park ordered Nakamura to replace the welded track sections with factory components as soon as supply convoy arrived, then departed to inspect other tanks in the company. Chen waited until Park was out of earshot before turning to Nakamura. "Corporal, you're going to keep those welded sections on your tank until they actually fail, or until someone with more authority than Lieutenant Park tells you otherwise. Document everything. Track wear, stress indicators, any sign of structural compromise. If this repair technique is reliable, the whole Corps needs to know about it." The documentation that Nakamura compiled over the following 3 weeks would eventually revolutionize how the Army approached field maintenance for tracked vehicles, though the institutional resistance would delay adoption for months and cost lives that could have been prevented. Between November 4th and November 26th, Nakamura's welded track sections accumulated approximately 180 miles of combat operations across Peleliu's brutal terrain. The tank participated in 4 additional major engagements, crossed countless obstacles that stressed the suspension and tracks, and operated in conditions that the Ordnance Department would have classified as accelerated wear testing. The welded sections showed no signs of failure. No cracks developed in the weld metal, no structural deformation occurred, no connector bosses broke away under load. If anything, the repaired sections outlasted the factory track blocks on the same tank. By November 20th, 3 original track blocks on the left side had developed cracks in their connector bosses and required replacement using standard procedures. The welded repairs Nakamura had fabricated continued functioning without maintenance. Lieutenant Park inspected the tank on November 27th, 3 days after the island was declared secure. He measured the welded track sections again, photographed them from multiple angles, and reviewed Nakamura's maintenance logs, documenting every mile and every combat engagement. What he found contradicted everything his engineering education had taught him about precision manufacturing and tolerance requirements. Park's report to the battalion maintenance officer, filed November 29th, was remarkable for its honesty. Corporal Nakamura's field-fabricated track sections have demonstrated durability exceeding factory-manufactured components under identical operating conditions. The welded construction appears to provide superior structural integrity compared to pinned connections. Recommend formal evaluation of field welding procedures as authorized alternative to component replacement. That recommendation initiated a testing protocol at Army Service Forces Pacific Headquarters that would take 4 months to complete, and another 2 months to translate into revised field maintenance procedures. During those 6 months, combat units throughout the Pacific Theater faced identical track damage situations and followed standard procedures that left tanks deadline, awaiting replacement components that often took weeks to arrive. The mathematics of institutional inertia were brutal. An estimated 240 Sherman tanks across 6 infantry divisions experienced track damage severe enough to require block replacement between December 1944 and May 1945. Standard procedure required those tanks to wait for factory components shipped from the United States, a process that averaged 18 days from damage report to repair completion. Nakamura's welding technique could have completed those same repairs in approximately 6 hours using materials already present in theater. The accumulated combat ineffectiveness represented roughly 4,320 tank days of operational capability lost to a supply chain problem that field welding could have eliminated. But the Army in 1945 was an institution that moved slowly, that valued centralized authority over distributed decision-making, that trusted engineers in Maryland more than corporals in the Pacific. Change required overcoming bureaucratic friction that measured in months rather than days. The formal testing began in March 1945 at the Army Service Forces Maintenance Depot on Okinawa. Nakamura was pulled from his unit and flown north to serve as primary instructor and demonstration technician. For 2 weeks, he taught a dozen experienced tank mechanics the welding procedures he'd developed through trial and error, showing them how to select salvageable material, how to build up damaged sections through multiple weld passes, how to verify structural integrity through visual inspection and simple mechanical tests. The depot's testing protocol was refreshingly practical compared to the theoretical analysis that had delayed approval for so long. They simply took damaged track blocks, repaired them using Nakamura's methods, installed them on operational tanks, and documented what happened. Across 89 separate repair instances, 0 failures occurred during the testing period. The repaired sections accumulated approximately 3,400 miles of operation without any structural problems. The cost comparison was even more compelling than the reliability data. Each factory-manufactured track block cost the Army approximately $67, including shipping to forward areas. Nakamura's field repair technique used approximately $4 worth of welding rod and consumed about 3 hours of mechanic time. The cost ratio was approximately 1:17, though that calculation didn't account for the operational value of keeping tanks combat effective rather than deadlined awaiting parts. The revised technical manual TM-759, covering Sherman tank maintenance procedures, was published in July 1945 with an entire new section on field welding of track components. The procedures were described as emergency repair methods authorized when replacement components were unavailable, though the testing data clearly showed the repairs were often superior to factory components. Nakamura's name appeared nowhere in the manual, consistent with the Army's practice of crediting institutional testing, rather than individual innovation. James Nakamura received a Bronze Star for his actions on Peleliu, though the citation carefully emphasized his tank's combat effectiveness while avoiding any mention of unauthorized repairs. He remained in the Army through 1946, participating in the occupation of Japan and eventually serving as a liaison with Japanese civilian mechanics during the demilitarization of their armored forces. The irony wasn't lost on him. He'd grown up watching his father's Japanese welding techniques, carried those techniques into the American Army where they were initially condemned as violations, and now was using them to teach Japanese mechanics how to maintain American equipment. After discharge in 1946, Nakamura returned to Sacramento and joined his father's fabrication shop, though the business had been destroyed during the forced relocation of Japanese Americans in 1942. They rebuilt it slowly, taking on repair work that other shops wouldn't touch, building reputation for solving problems that supposedly required replacement rather than repair. Nakamura never gave interviews about his military service, uncomfortable with the attention that arose whenever military historians discovered his role in developing techniques now considered standard practice. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.